Heavy industry as we know it is about to change. And these might be the biggest transformation since the Industrial Revolution of the 19th century. With the EU's strategy of reaching zero greenhouse gas emissions by 2050, heavy industry needs to look for radical changes to cut down emissions, reduce waste, and digitize their production processes. And the change needs to happen now.
We should make no mistake. The battle of industrial data starts now. This is why the technologies that allow data collection and processing are of a strategic nature.
With a large group of industries in dire need to step up their digitalization efforts, help might come in the form of a 3D printable IoT device, no larger than a small six-sided dice.
What we have here is a Bluetooth low-energy device coupled with the sensors, programmed to gather data on position, velocity, and g-force. This data is collected and interpreted by the software, and based on the programmed function, can send an information to the cloud or directly to other similar devices.
So how can a small, replicable microcontroller help heavy industry meet the demanding norms? Imagine a factory full of mechanical robots automating production processes. This robot, for example, produces dice, guaranteed to result in a 6 every single throw. The process considers minor discrepancies. The robot might produce a dice rolling 2s or 3s. This will qualify as waste. Occasional discrepancies are part of the industrial production process, and there are procedures aimed to mitigate these. For example, many industrial production robots are designed to perform regular calibrations. But regular calibrations mean regular stoppages and delays, which is far from perfect when thinking about production efficiency. What may seem like a miniature waste for a single robot or a single production line, when measured on the scale of a whole production facility, can amount to significant wastages. This is something no industry can afford. According to a recent McKinsey study, introducing a data AI strategy can deliver breakthrough results in lowering industry wastages. An introduction of detailed assets monitoring devices can help build data patterns for every device in the entire factory. And by linking multiple assets together, you can create a self-monitoring network with machines recalibrating to the best performing template. And that is what multiple industries are trying to achieve. Yet over 2/3 of companies pursuing digital manufacturing initiatives fall into the pilot trap. In an industry where replacing assets with newer and more advanced ones is an option too expensive to easily justify, the solution needs to be small, cost-effective, and replicable. A 3D printed low-energy Bluetooth device might be able to meet these criteria.
As this is relatively inexpensive products, you can have multiple similar black boxes, gather complex performance, and share the data with other assets in your factory.
The device's miniature size allows it to be contained in a small package and 3D print a specific shape to fit in any existing equipment. A layer of custom protective coating can shield the device from any environmental factors like heat, humidity, dust, or radiation. Two-way communication between the assets and with the IIoT analytics platforms opens doors to cloud-based data analysis and thus allow for the introduction of AI and machine learning algorithms on gathered data. The advantage of using a replicable tracking device across multiple devices in your factories allows you to quickly build a unified data and performance tracking network on the entire production and shipping processes. This small IoT device could be a groundbreaking step in winning the fourth industrial revolution.